All right, here we go. 10.7, second day of locus problems. 1 through 12 all, homework. All right, locus problems. So yesterday or last class, you were introduced to these things called locus not without a T. And the definition of locus was the set of points that satisfy one or more conditions. Example I gave you yesterday, you have a given. Now, formally, you did the homework last night, so usually don't literally break it down into given and conditions, but you will be given a set of instructions of how to start the problem. For instance, you're given point A is the start. Then you'll either be given a condition for a locus problem or a set of conditions for a loci or loci problem. So this particular one's a locus, so you're going to get one condition. So it's the set of points that are 1 centimeter away from A. Now, it does say on a plane. Remember, that's the key of whether or not this is 3 dimensions or 2 dimensions. So it says on a plane, so it's flat. We're in 2 dimensions. And if you think about all the points that could be a centimeter away from A, it makes a circle. Now, technically, the answer can be a picture for this one. If you have it as a picture, you just to make sure you indicate very clearly that the circle is the answer. Or you could write this out in words. So this is a circle, has a radius of 1, has a diameter of 2. Any of those would be fine answers. Okay, so this is what homework looked last class, because we only had one condition. And then give you an example of one of them in 3 dimensions. How do I know this is 3 dimensions? Because it says the set of points 1 centimeter away. It doesn't say on a plane. So my given is a segment. If I'm 1 centimeter away from that segment, I'm either above it, below it, but since it's not on a plane, I could wrap all the way around segment AB, so that would make a cylinder, and now I got to include the endpoints. So if you're 1 centimeter away from A, you would be a hemisphere, and remember, I couldn't draw the hemisphere very good, so I just tacked on 2 spheres. So this is that pill, that hot dog, however you want to describe it. Okay. Today we're only going to do 2 examples. Yesterday or last class we did 4. Today we're only going to be doing 2 examples, and they will be sort of challenging. So, new definition. The evil twin of a locus is a loci or loci, it can be pronounced either way. And it looks like the same definition, except it says satisfy 2 or more conditions. Most of the time in the homework, we're only going to have 2 conditions, but it could be 12 conditions. So go ahead and copy that one down. All right, so I said 2 examples. Here we go. I'm going to set up the same way with given conditions. Remember, the answer is what shape or what points do it make. All right, so here's my given. I have 3 coplanar, non-collinear points, and they're named A, B, and C. So let's unpack that, and I'll show you the condition. The set of points 1 centimeter away from A and equidistance from B and C. So in this particular one, we have, let's see, how many conditions here? We have 2 conditions. In red is the first condition. It's the points that are 1 centimeter away from A. And the second condition is they also must be equidistant from B and C. So there's many different ways of doing this. This is my recommended way. If you have 2 conditions, I want you to draw each condition separately so you can at least wrap your head around it. So if I were to draw each condition separately, well, I would have to start off each time with the given. And the given is, let's see, 3 points that are on a single plane, coplanar, and they don't make a line. So there's my A, B, and C. Notice they are all on the screen, so they're flat, and they don't all line up in a line, so they're non-collinear. Now, if I have 2 conditions, I need to draw this twice. So the condition, the first condition in red, I'm going to draw the for those 3 points that are on the left, and for the, I think it's purple, for those condition that's in purple, I'm going to draw it right there in the middle. And then my answer, the loci or the loci, would be those 2 pictures joined together. So I'll end up having a third one as being my final answer. Now, some students would say this is way too much work. I can do the whole thing in my head. Okay, I wouldn't disagree with that. But for students that have problems with, I don't know, doing this in your head or trying to do the spatial orientation of how all this works, I find out this technique works well. So if you have 2 conditions, you're going to draw it 3 times. The third one is going to be the first 2 joined together and what they have in common. All right, so let's see if I can make this happen. So the first set of conditions is the points that are 1 centimeter away from A. So this sounds like a problem that we had from yesterday in our homework. Well, if I'm 1 centimeter away from A, we already know what that is. That's a circle. So that red circle right there represents condition number 1. Now I'm going to switch to those 3 points in the center, and I'm going to do condition number 2. So condition number 2 also sounds like a homework problem we had from yesterday. It says the points that are equidistant from point B and C. So if you are equidistant between point B and C, I think you could probably come up, I'll go ahead and draw this. You could probably immediately come up, well, then I must be right here in the center. Well, yeah, this blue dot I just drew is equidistant from B and C, but so is this blue dot. And what I mean is that this second blue dot is the same distance away from B as it is away from C. But if that's true, then so is this point. This point is the same distance away from B and from C. And if I continue that process over and over and over again, I think you can see what we're going to get. What we're going to get is we're going to get a line that is spaced right in the middle between B and C. So every point along that red line there would be equidistant between B and C. Now, I said we're going to do this 3 times. So the third time is the answer. And the answer would be what would happen if I combined the condition on the left with the condition in the middle there. In other words, I'm going to draw them both at the same time. And where would the red overlap? So on the third one, the final one, the answer, let's see, there's my first condition. There's my second condition. Now, where does the red overlap? Well, the first red is a circle. The second red is a line. So there would be 2 places there in black, I believe that maybe that's blue, that they overlap. So the overlap is the loci or the loci. That is the answer. So it looks to me that the answer, if we're given 3 coplanar non-collinear points A, B, and C, and the condition is the set of points 1 centimeter away from A and equidistant from B and C, it looks like the answer is going to be 2 points that are 1 centimeter away from A if you really want to be particular. But we got a problem. And yes, that is an answer, but it isn't the final answer because we run into a problem. Now, hopefully all that made sense, and that's literally what you're going to do. But maybe, I don't know if you had the question when I was starting this, some kids catch on very quickly, but there was a problem right from the very start. So yes, 2 points is an answer. It just isn't the only answer. And the huge but right here is the problem is that, well, it was how I drew that. I mean, how did I draw A, B, and C? I just went ahead and drew A, B, and C any old way. But what's to say that it looks like that? It doesn't say how the 3 points are arranged. It simply says they're on a plane and they don't make a line. Well, right there is one way of drawing A, B, and C, but there's other ways of doing it. So if I draw A, B, and C like that, yes, the answer is 2 points there in red. But what happens if I move point A? And what happens if I move point A away to about that location right there? If it's in that location, I'm still a centimeter away. There's the line that's between B and C. And now the only overlap is not 2 points, it's 1 point. And lastly, well, what happens if I move point A far, far, far away? Well, now nothing overlaps. So the answer is they have nothing in common. There's no points. So boy, do loci problems bring up issues. Loci problems require you to do a lot of thinking about what can happen. Sure, we could get 2 points in common. Sure, we can get 1 point in common. Sure, we could get no points in common. And believe it or not, that's the actual answer. So the actual answer to this is 1, 2, or no points. And that's a lot of thinking for one little problem. Hence, we're only going to be doing 2 of these. And for tonight for homework, you're going to have to do a lot of thinking about these. Okay, so there's example number 1. Notice we did this in 2 dimensions. How about now we do this in 3 dimensions, right? So we're just going to do one more. It's going to be, and all of these are fairly challenging. And remember, we got to think in 2D and 3D. So let's do the same problem, except this time, let's do it in 3 dimensions. So once again, how I would recommend to do this is that step number 1, you find out how many conditions you have. We got 2 conditions. draw two sets of the given, and then combine them to get the final answer, the third set. So once again, there's A, B, and C. I need to do it 3 times. If I'm 1 centimeter away, but I'm not on a plane, well, then I'm a sphere. Now here comes the problem. Now we got to think this through. Let's see. If I am equidistant between B and C, but I'm in 3 dimensions, I'm no longer a line, I'm a plane. Any dot I draw on that blue plane right there would be equidistant from B and C. So it's not a line anymore, it's going to be a plane. And this works really good in person. I actually grab a hemisphere, 2 hemispheres in a plane, a flat sheet, and I put them together to see what they make. So maybe you can imagine what this makes. If I combine a plane with that sphere, I would get, well, what would I get? Well, what you would get would be, remember, a sphere isn't like an orange, right? Doesn't have a center to it. It just has a skin to it. So the sphere only has a skin. It's the outside, or the surface area of the sphere is the sphere itself, nothing on the inside. The plane is just a flat, think of it as a flat sheet of paper. So if you just had the skin of an orange cut in two and squeezing a piece of paper, well, the only part of the orange that would touch the piece of paper would not be a disc, it would be a circle. So in this orientation, I probably shouldn't have colored that in blue, but I did. And this gives you the impression that it includes the center. It does not. It's just a circle. So a circle, right? Oop, I already given you all the answers. A circle would be the loci or the loci given in those conditions. And then we run into that same problem is, well, how do we know where A is, or B and C for that matter? If I take that sphere and push it to the right or push it to the left, eventually I'm going to touch that plane in only one spot. Or if I move it even farther to the left or the right, it will never touch that plane. So therefore you get, this is the final answer. You either get a circle, and it should say 1 point, or no points. And that's the answer in yellow there. Boy, that's a lot of thinking. All right, so yes, indeed, ugh, right? It will be challenging. So when we look at the homework, make sure you, well, a couple things. We'll make sure you understand whether you're in 2 dimensions or 3 dimensions. Make sure that you understand the conditions, how many conditions there are. And if you need to draw it in multiple iterations and then push them together at the very end, that's a pretty good technique. Some people can do this without doing any of that. They can just read it, and in their heads, they can do this construction. Hope if you're one of those persons, good on you, but a lot of people are not. A lot of people actually have to draw it. I'll accept either an answer or the drawing. Either one would be fine. All right, so there's your homework again, and that'll be it for this class.